We're going to turn our attention now to what the atmosphere looks like. In this video, we're going to look at where the atmosphere came from, as well as what is the atmosphere composed of today. So, the very first few years of the Earth's existence, it was nothing more than a bunch of rocks that had collected and formed into a planet. The gravity of all of those rocks pulled those rocks together and heated them up so much that they melted and turned into a big ball of molten rock. That was our original Earth. Now, as this happened, some of the lighter gases, such as hydrogen and helium specifically, they floated kind of to the top. So as the Earth started to harden, cool and harden, the hydrogen and helium was left outside. And this was our original atmosphere, a big ball of cooling molten rock with hydrogen and helium all around it. Now, as the crust continued to cool, there were still pockets of gases inside. And whenever there were fissures in the crust, they would find a way to escape. This process is called outgassing. And the main elements that we got from this are water, carbon dioxide, and nitrogen. Water is this element H2O you see in the slide here. Carbon dioxide is CO2, and nitrogen is N2. Okay? So now we've got an atmosphere of hydrogen and helium, which are the lighter weight gases. They're kind of floating on top, but primarily our gases in the atmosphere are now water, carbon dioxide, and nitrogen. Now, as the amount of water in the atmosphere accumulated, pretty soon there was enough water for the water to condense and form clouds and eventually rain. And over thousands and millions of years, this rain kept falling and accumulating to form lakes and oceans. Now, lakes and oceans are actually really good at absorbing carbon dioxide. We actually see this fairly frequently in our everyday lives. Have you ever drunk a can of soda? What makes soda? Carbonated water. Carbonated water is just carbon dioxide dissolved in water. Now, this will play more of a role when we talk about climate. So just hold on to that thought, and we'll talk about that towards the end of the course. But as the water and the carbon dioxide start coming out of the atmosphere and settling onto the surface, the nitrogen remained. Nitrogen is made of two nitrogen atoms that are bonded together to form nitrogen gas. So this nitrogen just stayed in our atmosphere. And so you can see our atmosphere starting to evolve a little bit more. But now that we have water, pretty soon we started to develop plants, and they started converting what carbon dioxide was left in the atmosphere into oxygen. This process continued with water, carbon dioxide being outgassed, and then water condensing onto the surface and the carbon dioxide being absorbed into the water. This happened over millions of years, hundreds of millions of years. And the plant life during that time kept building up the oxygen in the atmosphere. And so we end up having this play of what the atmosphere is made of. But the entire time, the stable nitrogen stays in the atmosphere. So today, what is our atmosphere made of? Well, 78% of our atmosphere is nitrogen. Nothing was happening with this nitrogen. It just kept building up in our atmosphere. And only about just under 21% of our atmosphere is made of oxygen. Now, there are other elements that are in our atmosphere, like less than 1% of our atmosphere is made of argon. We have some neon, helium, hydrogen, xenon. These are some pretty typical gases in our atmosphere. We also have some variable gases where the amount of those gases change from time to time. Water is the most prevalent of these. Water vapor has so much variation in its concentration in our atmosphere that we have to say anywhere between 0 and 4% of our atmosphere is made of water vapor. This is the most variable gas in our atmosphere. Carbon dioxide is, of course, another big one, as is methane, and there are others such as ozone. Okay, now, one last thought. Nitrogen? I thought we wanted oxygen. Don't we want our atmosphere to be made of oxygen? That's what we need to live. Well, that would also pose a huge problem if we had an oxygen-rich atmosphere, because oxygen is flammable. If you just have one spark in an oxygen-rich atmosphere, the atmosphere would ignite and you would have no more atmosphere. Okay? So honestly, the nitrogen that we have is very stable. It's very good that 78% of our atmosphere is made of nitrogen. Just a very quick story to illustrate how flammable oxygen is. Of course, we know about the Apollo missions that took man to the moon. All right. The very first Apollo mission, however, was a tragedy because they were in just a regular routine training, and someone flipped a switch and there was a spark. What we didn't understand, though, was the hazard of training in an oxygen-rich atmosphere. The air inside of that capsule was primarily oxygen. And so as soon as that switch was flipped and there was a spark, it ignited, and within 30 seconds, all 3 members of the crew had died. Very sad story. But just to illustrate how important it is that we have this nitrogen, the stable nitrogen in our atmosphere. In our next videos, we're going to start looking at what the atmosphere itself actually looks at, like if we look at it using different variables within physics.